Hello students, welcome to Sri Vardhaman Vidyalaya online education. Today we will see the chapter 9 physics part force and law of motion numerical part. So in this part we will see some illustrations regarding the force and law of motion. So example 1, a constant force acts on an object of mass 5 kg for the duration of 2 seconds. It increases the object velocity from 3 meter per second to 7 meter per second. Find the magnitude of the applied force. Now, if the force was applied for the duration of 5 seconds, what would be the final velocity of the object? So, what is given in this one? So here it is given initial velocity is given, that is an 3 meter per second, and final velocity given as an 7 meter per second, and also the mass is given, that is 5 kg. Okay, so you know from an equation 5, that is F is equal to m into v minus u upon t. Now you can substitute this, and the time is also given, that is an 2 seconds. So when you substitute this value in the relationship, that is a mass is a 5 and v is in a 7 meter per second square and u is in a 3 meter per second square and time is in a 2 seconds. So you get 7 minus 3, that is in a 4. 4 into 5, 20. So 20 upon 2, that is 10 Newton. So the force is equal to 10 Newton. Now second questions. Now if this force is applied for the duration of an 5 seconds, so the time is in a 5 seconds, then what about that final velocity? So you have to find out the final velocity. So we have learnt in a chapter 8, that is v is equal to u plus a t. Okay, so in this one, instead of an a, we can write that is an ft upon, that is an t is an given, that is f upon m. How? Means, so in a Newton's second law of motions, we have find out the derivation for the force, that is force is equal to mass into acceleration. So what about the acceleration? Acceleration is a is equal to f upon m. So instead of an a, here you have to substitute f upon an m, and that is already an t. So now the equations will become v is equal to u plus ft upon m. So when we substitute this one, that is an initial velocity is an 3 and force is an 10 and the timing is an 5 and the mass is also an 5. So 5 will be cancelled. So now remaining initial velocity is 3 plus Newton is an 10. So we will get a final velocity, that is 13 meter per second. 30 meter per second. Okay, so like this we can find out the force as well as a velocity, that is a final velocity. Second example, which would requires a greater force? The accelerating a 2 kg mass at a 5 meter per second square or 4 kg mass at 2 meter per second square. So what is given? So force is given and acceleration is given. You have to find out that is mass is given, acceleration is given. You have to find out a force and which will have a greater. So first one, just we have to change the equation. So here F is equal to ma. What you have to find out? Force you have to find out. So m1 is a 2 kg, acceleration a1 is given as a 5 meter per second square. Same thing, m2 is given as a 4 kg and a is given as a 2 meter per second square. Now F1 is equal to M1 into A1, that is 2 into 5, 10 Newton. So F2 is equal to M2 into A2, that is 4 into 2, that is 8. So which force will be greater? That is F1 is greater than F2. So the accelerating and a 2 gram mass of 5 meter per second square would require a greater force. So that you have to find out. So example 3, a motor car is moving with a velocity of 108 km per hour and it takes 4 seconds to stop after the brakes are applied. Calculate the force exerted by the brake on the motor car if its mass along with the passenger is 1000 kg. So mass is given, that is an 1000 kg. Initial velocity is given 108 km per hour and the time is given 4 seconds. So first of all, you have to change the unit. So in the is you have to change in an SI unit, that is in a kilometer per hour, that will be changed into a meter per second. So already we have studied in the chapter 8. So kilometer will be changed into meter upon, that is an by 1000, and hours will be changed into a second, that is an 60 into 60, that is 3600. So like this. So the initial velocity of the motor u is equal to 108 kilometer per hour, that is 108 into 1000 upon 60 into 60. So this will gives an answer, that is 30 meter per second. Now the final velocity of a motor here we are taking as an 0. Now the total mass of the motor along with the passenger is 1000 kg. So mass is given as an 1000 and time is given as an 4 seconds. So now we can substitute, that is an F is equal to m into v minus u upon t. So m is an 1000, v is an 0, u is an 30 upon 4. So when you cut this one, you will get an a minus 7500 kilogram meter per second square, that is equal to minus 7500 Newton. So the negative signs will tells that the force exerted by the bike, means brake, is opposite to the direction of the motion of the motor car. Means the when we apply a force, what happens? The force exerted by a brake is opposite to the direction of a motor car. So that's why the negative sign will be given. Next, example 4. A force of 5 Newton gives a mass of m1, an acceleration of 10 meter per second square, and a mass of m2, an acceleration of 20 meter per second square. What accelerations would it give if both the mass were tied together? Okay. So what is given here first? Acceleration, that is a1 is given as an 10 meter per second square, and a2 is given as an 20 meter per second square, and force is given as an 5 Newton, and mass is an m1 and another mass is an m2. So first we have to find out an mass m1 and m2. So we know that is an F is equal to ma. So m1 is equal to F upon a1 and m2 is equal to F upon a2, because the force is common for both. Now from this we can find out m1, that is an Newton is an force is 5 and acceleration a1 is an 10. So the 5 upon 10, that is 0.50 kg. Next m2 is equal to 5 upon 20. So it will become 1 upon 4. So that is equal to 0.25 kg. When we mass, so what is given? You have to find the acceleration, that is a. If enough both mass will be tied together. So first we have to add this one, m1 and m2. So that is 0.5 plus 0.25, it will become 0.75. Okay, now force is given, that is an F5. So you have to find out an A. So A is equal to what? F upon M. So that is 5 into 0.5 kg, that is equal to 6.67 meter per second square. So this will be the answer, that is an accelerations where if both and a mass will tie together, that is 6.67 meter per second square. Example 5. Here the graph is given. So that is velocity time graph of a ball of mass 20 kg moving along the straight line on a long table that is given. So the velocity and time graph is given. Okay. So how much force does the table exerted on a ball to bring it to the rest? So you have to find out the force does the table exist on the ball to bring the ball to rest. Okay. Now here from this graph we can find out the initial velocity of an ball. So here the unit is given as a centimeter per second square and here it is in a second. So first we have to find out an velocity, that is an initial velocity as well as an final velocity. So the first initial velocity is given as an 20 centimeter square. Due to the friction force exerted by the table, the velocity of a ball will be decreased. So here it is u, so the velocity will be decreased and it will become a 0 in the time 10 seconds. So u is equal to 20 centimeter per second square and v is equal to 0 and time is equal to 10 seconds. Okay. Now since it is in a straight line, you can say that is the ball is moving with a constant accelerations, because the velocity upon time is an acceleration. So the acceleration a is equal to, you know, that is an v minus u upon t. Okay, so that is from an equations v is equal to u plus at. So a is equal to what? V minus u upon t. Okay, so we know that is what is v. V is in a 0 and u is equal to 20 centimeter per second square, and time is in a 10 seconds. Okay, so from this we can calculate the, so we have substituted the value, that is v is equal to 0 and u is equal to 20 and time is in a 10 seconds. So you will get an a minus 2 centimeter per second square, so that you have to change into meter per second square. So you have to change, so you'll get an a 0 minus 0.02 meter per second square. Why here it is in a negative sign? Because it will be decreasing, that is a negative signs will indicate a retardation. The force exerted on the ball, so F is equal to what? Mass into acceleration. So mass is given as an, you have to find out an force. Okay, so mass into acceleration. So mass is given as an 20 upon 1000 kilogram. So that is an 0.02 meter per second square. Okay, so why it is given as an 20 upon 1000? So what is given here? Vishinj. Okay, so now you can divide, so you'll get an a minus 0.004 Newton. So the negative sign indicates the frictions force exerted by the table is opposite that to that of the directions of motion of an a ball. Okay, so here mass is given as an a what? 20. Okay, so you have to find out the force. So force that we can mass, that is we can find out. How we can find out the mass? You know, that is, and a mass is equal to F upon A. Okay, so A is we have find out. So we can find out an mass. So 20 upon 1000, we will get an answer, that is 0.004 Newton. Thank you. We will see the next illustration in the next part of this session.